In order to find critical values in a hypothesis test, the first thing that you're going to do is look at what type of test you're doing. So in this first scenario, we're given that the null hypothesis is mu is equal to 12, and the alternative hypothesis is that mu is not equal to 12. And this tells me that we are doing a two-tail test. And I'm also given the significance level alpha, which is 0.05. So what I'm going to do to find my critical values that are going to determine my critical regions or rejection regions is I'm going to come over to the normal distribution, and because this is a two-tail test, I'm going to mark both of my tails here. So I'm going to have critical regions on both sides of the graph. And I'm not particularly concerned with exactly where I'm placing this boundary. That's what I don't know. That's what we're trying to find out. So since alpha is 0.05 and we're doing a two-tail test, I have to take alpha and divide it by 2. So I divide that and I get 0.025. And so this value is going to be z sub 0.025 because I have 0.025 in this tail. And then this value will just be the negative of that. So I don't really need to calculate both of these in the calculator. I just need to find one of them. The other one's going to be the negative of that. So to find z sub 0.025 in the calculator, I'm going to use the inverse norm function the way we did back in chapter 6. So inverse norm, and I'm going to compute 1 minus 0.025. The mean is 0, and the standard deviation is 1, because we're working with our standard normal distribution. And when I calculate this, I get positive 1.96. So that tells me that my critical values are plus and minus 1.96. This is the positive 1.96 on the right, and then on the left-hand side I have negative 1.96. So those are my two critical values. And then, if we were actually proceeding with a problem, then I would look at the test statistic and say, is the test statistic falling in one of my rejection regions, either on the left or the right, or is it falling somewhere in the middle? So if it falls in the rejection region, I reject the null hypothesis. And if my test statistic falls in the middle, where it's not shaded, then we fail to reject the null hypothesis. Okay, let's take a look at another type of test. So now I have my null hypothesis says that mu is equal to 12, and my alternative hypothesis says that mu is less than 12. So this is a left tail test. This is a little easier than a two-tail test. So I take my alpha, which is 0.01 in this case, and it's all going to be on the left-hand side. So I'm going to mark that on my graph, and I'm really just approximating at this point. And this little area that goes into the left-hand tail past my critical value, that's 0.01. So what I'm calculating here is really negative z sub 0.01. And I can do that by finding inverse norm. And since for this critical value we have 0.01 on the left-hand side, that's what I'm going to do here. I'm just going to say inverse norm of 0.01, the mean is 0, standard deviation is 1. And when I calculate this, I get negative 2.33. So that's my only critical value. We just have one critical value if it's either a left tail or a right tail test. It's only with the two-tail test that you get two critical values. Now let's try one with a right tail test. In all of these problems, I've used a null and alternative hypothesis involving mu. And I would do this exactly the same way if the parameter were p. So that part really doesn't matter at all. And now we have alpha is 0.02. And this is a right tail test. So I'm going to mark 0.02 on the right-hand side, estimating where that z value is. And this is going to be z sub 0.02. It's positive because it's on the right-hand side. So now I'm going to do inverse norm of 1 minus 0.02. Because remember, we're always taking inverse norm of the area to the left. Now, some calculators have a special feature where they let you say whether the area is on the left, the center, or the right. And so then you can adjust accordingly. But most calculators will just have you, they assume that the area is just on the left. If they don't specify, that means that the area has to be on the left-hand side. So I have to do 1 minus 0.02 in order to get that area on the left. And when I calculate this, I end up with 2.05. So that's my critical value in this case. And that's how you find your critical values.